keep the data in the file system, so we need to have the different data structure. Okay, so the last part of the semester we will talk about the I/O management, including the file system. So these three are the main part of the semester in the operating system. However, there are more the topics. First, the security. And nowadays the distributed, the operating system, and so on. So, and also virtual machine. If we have time, so we will talk about the advanced topic of the operating system. But first, we are going to finish these three main parts. The first part is the creating process, the process management, and the memory management, and third, the I/O management. So these three parts, if we have time, we will talk about this one. Going back to the creating process, a little bit more. So creating process. So if we have just like the MS-DOS, if we have the single process operating system, it's not very complicated. So we can create the one process, then the run, and that's it. Okay, the next one, and bring it, and that's it. However, the operating system is kind of fighting with the limited resource. So when you purchase the computer, everybody wants to have the fastest CPU and the bigger size of memory and the bigger size of the hard disk drive or SSD. Why? Performance. The main reason why we are using the computer is we try to compute something, data, information, the whatever. Anyway, we try to process very fast, so better performance, higher performance. But problem of the better performance, good performance is the limited resource. So think about, for example, the CPU. How many CPU you have? So nowadays, the quad core, yes, that is popular. So one CPU has the several core or the multiple CPU. Some of the computer has a multiple CPU, but still, let's say the dual core. Dual core means in one chip there are two the core. Let's say that we have two CPU inside. Then at the same time, how many processors can you process? So only two. If you have the single core, you have the CPU time and you can process only one process, one set of instruction at a time. But everybody wants multitasking. Everybody wants the process at the same time. We cannot increase CPU time. Can you stretch out the time? No way. Okay? The only thing we can do is maximize the utilization. Okay? So this is one example of how to manage the process. We need to always fight with the limited resource. If we have unlimited resource, which is not possible, but suppose that we have the unlimited resource, our textbook will be less than 100 pages. Well, since we have the very limited resource, we need to maximize the utilization and maximize the performance, okay, and increase the throughput, something like that. Okay, so creating process and memory management and I/O management, all of these are fighting with the limited resource. So then what is the problem? How can we solve the problem of the limited CPU? When we run the multiple processes, we need to slice the CPU time. Okay, then we pretend. The good news is it's very fast. the CPU cycle is very fast. So sometimes we cannot realize, even though the slice and the changing and the take time for the process 1, process 2, process 1, process 2, human being cannot realize such a changing of the processes. So we need to do the schedule. So we are going to learn the first what is the process and how to create the process. Then the next topic is the how to schedule, how to deal with the multiple processes. That is called the CPU schedule. The problem when we create such a multiple processes, they are fighting each other. So they are accessing the shared data at the same time, which means we cannot guarantee the final output of the data. So to address such a thing, that is called the synchronization problem. So synchronization is not only the operating system problem, it's a general problem in any computer programming and application. So since nowadays we have multiple resource source of the data and many processes are sharing such a data, so we cannot guarantee the output of such a data after processing. So we need to synchronize such a thing. So we are going to talk about such a synchronization in chapter 5 and also 5, 6. And also, if you allow the shared data and multiple the processes, shared means any process can access the data. So sometimes we encounter problem of for example, I'm holding this textbook. I already check out, and he check out this textbook. But I need this textbook to finish my project. But he need my textbook to finish the project. So we are waiting each other. So this is called deadlock problem. So deadlock usually happen when we allow the sharing the data for the multiple processes. So operating system need to deal with such the deadlock problem. So these are the main topic of the process management for the first first half of the the semester. Okay, so it's time's up. So today we have seen the overview of what we are going to do throughout the semester from the next class. So we are going to start from the first. Before we start, we need to know what is the operating system and what is the computer and what is the requirement of operating system. We will talk about such an introduction of the operating system. Any question?